Welcome viewers to the last segment of the third lecture for the online series of lectures for the course of General Relativity. In this segment, we are going to discuss transformation of tensors under change of charts. Transformation of tensors under change of charts. Now consider chart phi x1, x2 all the way up to xn, and chart phi prime given by x prime 1, x prime 2 all the way up to x prime n. Take an element. Now we take an element from the vector space we discussed in the last segment. Take an element T at P belonging to this vector space. Calligraphic T sub P r comma s. We have seen earlier that we can write down this tensor as a linear combination of these basis vectors, the components of which is given by this expression T mu1 mu2 all the way up to mu r, mu1 mu2 all the way up to mu s. This component evaluated at P, and then we have the basis vectors del x mu1 at P, tensor del x mu r at P, tensor dx mu1 at P, tensor dx mu s at P. Okay. So this expression of TP is in the chart phi. Okay, the element T at P using chart phi. Okay, so this expression is written in the chart phi. Let us now write down T at P using chart phi prime. Okay, T at P is equal to T prime sigma 1, sigma 2 all the way up to sigma r, and then rho 1, rho 2 all the way up to rho s at P times tensor product of T del by del x prime sigma 1 at P, tensor all the way up to tensor del by del x prime sigma r at P, tensor dx prime rho 1 at P, tensor all the way up to tensor dx prime rho s at P. Okay, so this is the expression of T at P, the tensor T at P using chart phi prime. Okay. Okay, now recall from earlier discussions that the basis vectors for the tangent space transform under change of charts in the following way. Del x prime sigma 1 divided by del x mu 1 at phi of p and del times del by del x prime sigma 1 at p, and the basis vectors of the cotangent space transform as dx nu 1 at p is equal to del x nu 1 divided by del x prime rho 1 at phi prime p times dx prime rho 1 at p. Okay. So we have seen these results earlier. Okay. Now let us go back to this expression of the tensor at P in the chart phi. Okay. And erase everything else. Now, see that we leave the component as it is, t. In the superscript, we have mu1, mu2, all the way up to mu r, and in the subscript, we have mu1, mu2, all the way up to mu s. This component evaluated at p, and now you see that using the transformation of the basis vectors in the tangent space, which I wrote earlier here and then I erased it for creating room. Let me use those relations to write this guy as del x prime sigma 1 divided by del x mu 1 evaluated at phi of p. Okay. So I'm just writing the coefficients only of the results stated earlier. The corresponding basis vectors will be written down at the end. Okay. So all the way up to this comes from this, and from this we have finally del x prime sigma r divided by del x by del x mu r evaluated at phi of p. Okay. Good. And then we have from the expression. So using the formula for the transformation of the basis vectors in the cotangent space, we have del x nu 1 by del x prime rho 1 at evaluated at phi prime p. Okay, this comes from this dot, and from this we have a contribution del x nu s by del x prime rho s evaluated at phi prime of p. Okay, and then we write down the basis vectors in the phi prime chart, okay, which are as follows. The first one, the basis vector in the basis vectors in the tangent space in phi prime chart are del x prime sigma 1 at p, tensor all the way up to tensor del by del x prime sigma r at p, okay, and then tensor dx prime rho 1 at p, tensor all the way up to tensor dx prime rho s at p. Okay, from which, and we have seen that in the phi prime chart it is supposed to be equal to t prime sigma 1 sigma 2 all the way up to sigma r nu 1 nu 2 all the way up to nu s at p times del by del x prime sigma 1 at p tensor del by del x prime sigma r at p tensor dx prime rho 1 at p tensor dx prime rho s at p. Okay, so now compare this with this expression to obtain the following. Okay, so we see that the basis vectors, the tensor product of the corresponding basis vectors in the phi prime chart is the same as the basis vectors here in the phi prime chart. Okay, so the corresponding coefficients should match as well. Okay, so what are the corresponding coefficients? This is the coefficient here, and this part is the coefficient here. So let me erase this part. So we see, by comparing these two expressions, we see that t prime sigma 1 sigma 2 all the way up to sigma r rho 1 rho 2 all the way up to rho s at p is going to be equal to del x prime sigma 1 divided by del x mu 1 at phi of p del x prime sigma r divided by del x mu r at phi of p. Okay, good. And then with these contributions, del x mu 1 by del x prime rho 1 at phi prime p all the way up to del x mu s over del x prime rho s evaluated at phi prime of p times this coefficient, right, which is t mu1 mu2 all the way up to mu r, and then mu1 mu2 all the way up to mu s at p. Okay, so we have seen thus that this is how the components of a R comma S tensor transform under change of charts. Okay, good. So we end the third lecture here. Thank you for attending the last segment of the third lecture.